Hey, what's going on, folks? It's Mike here, and welcome to your next day in C. In this lesson, we're going to be learning a little bit more about the entry point function to our programs. That's the main function. So let's go ahead and talk a little bit more about this mysterious function where we always start our programs. So where I want to start here is just a reminder of what we've been doing in pretty much every one of our C programs. We've written int, main, no arguments, and then brackets, return, and then we write, our code here. And maybe we have some functions and other things that go on in our programs. But have you ever wondered, why is this main always empty here? Why are there no arguments here? Well, the reality is we could be putting in some arguments here, but where are they used and what's the purpose? So let me just go ahead and illustrate with a simple example here. So if you go ahead and open up any terminal, and I'll make it nice and big for you, oftentimes when you run commands like ls, or maybe even with our compiler for instance, gcc, you often add different arguments here. So I could do ls-l to list the contents here. Now this directory is empty, so it's not particularly interesting. So let me go back a directory here and do ls-l, and you can see a bunch of different files and so on. So what does that mean, or how do we get arguments into this program ls that's running on our command line? Or again, as another example, when I'm running GCC, the compiler we've been using, or maybe you've been using Clang, we provide arguments into this program, our compiler, meaning the file that we're compiling, where we want to output it, and so on. So we can have multiple arguments. Well, the answer to that is we actually can specify arguments here in main. And we'll need some information like the argument count and the actual strings passed in, which we indicate with char star star here. And this is just one of the variations of things that you can pass into main. You can also pass in something called an environment variable, but this is what you'll most commonly see in your C programs. Now, there is something a little bit strange here, though, this char star star. So we're going to have to talk about that and what exactly that means. It's the first time that we've seen two stars with a variable type name here. When we've seen one, we've known that's a character pointer. So what's a char star star? Well, we'll dive into that in this lesson as well. So let's just go ahead and get started by first creating a main file and looking at some of the arguments and the things that we can do. So I'm going to go ahead and split my window here, and let's just go ahead and create a main file here. And I'll write int main, return 0 here, and just set up our program to give us some standard input and output. Now, let's go ahead and try to run our program with these new arguments that I've said that you can set for main. And char star star and argv here. Now, these are a little bit strange names, so I want to explain where these came from in a moment, but first let me go ahead and just compile our program to confirm that this in fact can work. So gcc-g, because I like having the debugging symbols, main, and I'll output the program here, and it in fact works. The program doesn't really do anything interesting yet, but it does in fact work here. All right, now with that in mind, let's go ahead and figure out what these argc and argv variables are doing. So just to give you a little bit of a definition, argc is the argument count here, and argv is the variable arguments. Or if you like, you can just think of this as a list of strings here. And we've still got to talk about what this char star star is, but that's essentially the idea. So let's just go ahead and play around with some examples, and then we'll try to understand a little bit deeper what's going on here. So what I'm going to go ahead and do is just write a printf here and write %d, because we're going to want to sprint out the argument count here. And I'll just put argc here so we know what we're talking about, and argc. And let's just go ahead and start with that with our program. So I'll go ahead and run it, run our program, and you'll see the argument count is 1. Now, what is that one argument or one thing that we see here? Well, that's actually just prog here. Let's go ahead and try another example here where I run prog and I pretend that I can provide some input. So some input here. And now if I run it, I've got two arguments. The first being the executable name that we're running, and then whatever argument passes after. So let's go ahead and just run some other arguments here. Maybe I have 1, 2, 3, 4 here, and you'd expect 5 arguments here. So you can see that they are separated by spaces, and that's how we get the number of arguments here. So again, there's a space here, space here, space here, etc. And you count these in total, there are 5 arguments. So that's pretty cool because now we have a way to get feedback from our command line when we're executing our program of just what the parameters are or how many there are. Now, how can we use these? Well, let's go ahead and take a look at char ** here. Now, what I'm going to go ahead and do is just show how to print out each of the arguments, and then I'll talk a little bit more about char **. So let me just give you an example. So I know how many arguments I have here, argc. So I'm going to say, well, I is 0 and I is less than the argument count, and increment I. And then I want to print out each of the arguments. I'm going to print them out, and I'll put a tab in front here, %s, because these are going to be strings, and an end line just so that we can see them one line at a time, and the argument v and the index into it. Okay, and let's go ahead and make some recompile this since we've made some changes. And I'll rerun this just as such. And we'll see when we had one argument here, it was just prog. And if I run this again with an argument, so with no spaces between, we'll see that we have prog and an argument. And maybe I have something else like 1, 2, 3, 4, and so on. And we can see all of the individual arguments being printed out. All right, now what exactly is going on here? Well, again, we know about the argument count, but this argv I and how we're printing out this char **. And this thing's a little bit weird, so I have some slides to hopefully illustrate what exactly is going on or what this data type is. So bear with me for just a little PowerPoint presentation here. I know we love those, but essentially char ** is an array of strings. Or another way to think of this here is that it's a character pointer to character pointers. So a pointer to pointers. And well, we've looked at strings previously in a previous lesson, and a string in C, remember, is just a char *. It's a pointer to some block of memory where we have a list of characters and they're null terminated. So let's go ahead and look at how we would just create a char * if we wanted. So let's say I have a list of students here and I have char ***, and I can malloc, well, the size of a pointer, and I want 10 character pointers here. So it'll look something like this. We have a chunk of memory for our array. Each of these boxes big enough, it would be 8 bytes typically needed for a pointer to store that char * here. All right, so if I wanted to allocate a bunch of strings here for Mike, well, the first index into that char ** would be a pointer to some other string that exists somewhere. And the next one, and the next one, and the next one, and wherever we happen to allocate memory. So that's the idea here with a char **. So it's a character pointer to a character pointer, or a string if you want to think of it in sort of C terms, a C string. Bunch of character pointers to C strings. All right, let's hop out of the slides and look at the code again. So now let's just take a look at this and again, see if we can understand what's going on here. And sometimes it's more useful if I run with different examples, like with Mike here and, last name here, just so you can see the individual strings here. In fact, you can even wrap everything in a string here and be very explicit here, and then you'll just have one argument here that's listed. Notice that we're ignoring the quotations, but it's treating this as just one argument here because I've wrapped it in a string here. So let's go ahead and make use of this and try to write some interesting program or something that would take advantage of command line arguments. And what I'm going to go ahead and do is save this program here. And what we're going to do here is write the specification for what this program is going to do. This program will add 2 numbers and return the result to us. Okay, so that's all the program's going to do. So what we're going to want to do is validate our argument count. So for example, we'll run program, or maybe I'll rename it something like add, and I'll take an argument here and then an argument here to add these 2 numbers and print them off for us. And that's it. So go ahead and give yourself a moment to think. And if I wanted to validate the input to this program, that is make sure that argc is a certain number, what would it be to make sure that this program can in fact run and add 2 numbers? So if you thought about it, well, the answer is 3, because we have the program name and then each of the arguments here. So oftentimes what you'll see at the start of C programs is something of this nature. I'll say if argc is not equal to a certain amount of arguments or is less than or greater than something, then print to the user, printf, usage would be add and then 2 numbers here. Give the user a little hint on how to execute the program and then otherwise exit, or in this case, we could just return here. And I'll just return 0, so our program would terminate. Okay, so let's go ahead and let me make this a little bit smaller so you can see everything and try to run this program here. And what I'm going to go ahead and do is recompile it. And I'm going to call this program add, since we're doing addition and that's the purpose of this program. And I'll do add, and I'll not specify any program arguments here. In fact, let me get rid of this here so we don't have anything. And let's do add. And you can see immediately we've only detected 1 argument and we get a warning of the correct usage of this program here. All right, so let's go ahead and try running our program again with the correct usage, and we don't get this sort of error message coming out to us. All right, so now in our program, we can actually do the addition here. So what we're going to do is we will perhaps take the first argument, which is going to equal, well, is it the 0th argument or the first argument? Go ahead and think about that for a moment. If I'm looking at these, again, our arrays are indexed by 0. So this is 0, this is 1, and this is 2. And then we'll get the second argument, argv at 2. And then we'll print off the result here. And maybe I'll just save the result here. And result equals first argument plus the second argument. And we can print off some result here. %d plus %d equals some other result here. So again, we're just making this as nice of a output for our user here as possible here. And you're seeing me do some different things like use spacing and so on to try to make this program as neat as possible here. All right, so here's our actual program here. All right, now let me go ahead and recompile this. And looks like we've run into a little error here because recall that we're working with strings here and we have an integer data type because we're trying to write a program that adds 2 numbers together. All right, so let's try to figure this out. How can we convert a string type to some integer type? Well, I'm going to go ahead and give you a little assist here and show you a command here. And the command that we have here, let me make this bigger, is the string str to a long type here. Now I'm just using integers here, but a long is a bigger type of integer and it will implicitly cast for us. But let's go ahead and look at this function here. And if we go ahead and look at the manual pages, or you can go ahead and Google this, we'll see that this is a function that converts a string to a long integer here. So we have a few different arguments, meaning our string here. And we can also store where the first character is if we're provided some input that's not some numeric character. Because, well, I'm trying to convert a string to an integer, and if I have a bunch of letters or those kind of things, then the conversion will stop here. And we have our base for the conversion. And if I'm working with decimal numbers and the user is expecting to add decimal things, this is a base 10 system for decimal. Of course, you could do binary or something with base 2, hexadecimal 16, and so on. So let me leave this up just for a moment here while we use this function. Now do note that it is included in the standard library here. So I'll go ahead and include that library before we do anything else here. And oftentimes when I include a library, just stylistically, I like to say why I included it or what was the sort of purpose. So string to long here. And let's go ahead and use this function here. String to long, the argument. And I don't really care about storing the first invalid character here. And we'll have base 10 here. So string to long, and then again do null and a base 10 system. All right, let's go ahead and see if that did the trick. If I go ahead and recompile, and it looks like it did. So I'm going to just test our input again, make sure that we get a warning that our usage was incorrect. And let's try 1 and 2. And in fact, we get with our 3 arguments, 1 plus 2 equals 3. And we can try some different numbers here. And I can even add more arguments here, and well, it will again give me the usage that's wrong. If we wanted to, we could extend this to hand any number of numbers. So let's go ahead and do that. And let's go ahead and think how we might restructure this program. So instead, we'll have our result here. And I'm actually going to, since we could be storing bigger numbers, I'm going to convert this to a long and give it a start of 0 here. And then I'll just have a loop for int I equals 0. I is less than our argument count, I plus plus. And well, we've actually got to be a little bit careful here because we want I to start from 1 for our first argument. And what I'm going to do is in our result, I'm going to add to it our argv, converting each of those strings each time, argv at I. And we're going to use a base 10 system here. And then we can print out the result here. And I'll just print out the final result in our program here. So let's get rid of the rest of this text here. And we'll just have this result here. And because we can have any amount of arguments here, well, we need at least more than 1 argument here. So I'll say add and 1, 2, 3, and maybe ... here, so that somebody who's using our program would understand this pattern. Okay, so let's go ahead and recompile our program. And whoops, since I'm using a long, I need to change the type, and GCC is always helpful and tells me this is a long integer. So D is a specifier for integers, but a long one is LD. And let's go ahead and recompile this. I'm going to try it once just to confirm that I will get validation that my program's not working. And in fact, I usually don't want to print out the arguments here. So let me recompile this. I'll rerun here. Oops, this time I just get 0. So what happened here? Well, let's go ahead and actually keep our argc here. And I'll make sure I save, recompile. And if I run here, argc is in fact 1 here. So if it's greater than 1, oops, I've messed up here, my sign here. So if it's less than 2 is what I really need here. So let's just go ahead and validate here. We get our usage here. And well, we can't really add 1 number, but I guess this is fine here. We'll just get the result of 1 here. So that's still valid here. And we can add up all of our numbers here. So as many as we want here. And there's different ways that you could extend this. So a nice exercise for you might be to actually look at the individual characters and build a little calculator. So what do I mean by that? Well, maybe we would want to be able to just have a program called calculator and be able to do 1 plus 2 minus 5 or something like that. Now, if I try to run this, and I'll get rid of this with our current add program, it's going to sort of work in the sense that it is adding all these numbers and it is ignoring the arguments here that aren't digits, but we would actually want to check here to make sure that we're doing the appropriate operation and not just adding. So you could look at the command is digit, for example, and you would find in the C type library all sorts of functions to help you look at what your input is. Is it an alphanumeric character? Is it a digit? Basically, if it's not a digit, then you'd want to look up and detect is that string or the first character in a string a plus sign, minus sign, divide sign, and so on. So that could be an easy way to work with arguments. All right, folks, so that's where I want to end things here today. I hope this was a useful lesson and you learned a little bit something about C. And now you can write programs that take in commands as you run them. And again, why might this be valuable? Well, now you have a way to directly give input into your programs and just have them execute. And something neat that you can also do that's worth showing here, let me actually jump back into the screen, is when you write a program like this. So let's actually keep our add program here, and I do 1, 2, 3, 4 like this, where I added all the numbers. Well, now that I have this command line program, I can actually feed it into other commands I know here. So for example, the nl command will print out our results here and put lines in front of each of the numbers here. And that's this idea of piping the output from this program on the left side and making that the input or the arguments for this program on the right side here. So that's a pretty powerful idea, especially when you're using command line. So you can write these tiny programs like this little adder that we've written here and compose it to make more powerful programs that you just run on the command line. And you can automate different tasks and so on. So with that said, I hope you enjoyed this lesson and that you can see some of the power in now being able to provide arguments into your main function and execute your programs. If you found this lesson useful, make sure that you like and subscribe and comment below if you have any questions or other things that you'd like to see or be learning about in the C series. We'll continue the series. So again, make sure you don't miss any episodes and we'll see you next time, folks.